Hello everyone, I hope you are having fun learning about data and its representation. In the previous video, we discussed histograms and we saw how they are different from bar graphs. One interesting fact about histograms is that the width of the bars plays a significant role in its construction. In fact, the areas of rectangles are proportional to their corresponding frequencies. Let's take an example to understand this better. Consider the marks scored by 90 students in a class test out of 100. Let's represent this data using a histogram the same way as we did earlier. We represent the marks on the horizontal axis using a suitable scale. Observe that we have 3 different class sizes. 20 for the first class 0 to 20, 10 for the next 5 classes, and lastly 30 for the class 70 to 100. Here above means 100, right? Because the maximum mark is 100. Since the lowest class size is 10, let's choose the scale as 1 centimeter is equal to 10 marks. Thus, the markings are 10, 20, 30 and so on. As the interval is starting from 0, we don't need to mark a kink here. Next, we represent the number of students on the vertical axis. Since the maximum frequency is 20, let's choose the scale as 1 centimeter is equal to 2 students. Thus, the markings are 2, 4, 6, 8 and so on. Lastly, draw rectangular bars of width equal to the class size and lengths equal to the corresponding frequencies. So, in this way, we get the required histogram. Now, look at this histogram carefully. Do you think that it correctly represents the data? For instance, the class interval 70 to 100 has frequency 8 and the class interval 60 to 70 has frequency 15, which means the class interval 70 to 100 has less frequency than the class interval 60 to 70, right? But the histogram shows a greater frequency in the interval 70 to 100 than in 60 to 70. So it is clear that the histogram is not representing the data correctly. As we discussed earlier, the areas of the rectangles are proportional to their corresponding frequencies. But here, this is not the case. We didn't face this problem earlier. Then why now? Well, this is because in the previous histogram, the widths of all the rectangles were equal. Or put in simple words, the class S2 was the same for all the intervals. But here, we have 3 different class sizes, 10, 20 and 30. So because of the different class sizes, the histogram is not giving a correct picture. This means we have to change the lengths of the rectangles so that the areas are again proportional to the frequencies. And for that, we have to follow 2 main steps. Select the class interval with the minimum class size. In this example, the minimum class size is 10. So the first step is done. Now, for the next step, we modify the length of the rectangle proportionate to the minimum class size, which is 10 here. And how that is done? Let me show you. Let's start with the first interval, which is 0 to 20. Here, the class size is 20 and the length of the rectangle is 7. So, to modify the length of the rectangle proportionate to the minimum class size, which is 10, divide the length of the rectangle by class size and multiply it with the minimum class size. So, when the class size is 10, the length of the rectangle will be 7 divided by 20 into 10, which is 3.5. So now the length of the rectangle changes to 3.5. Now for the next interval 20 to 30, the class size is 10, which is the minimum class size. So no need to change the length of the interval. Even if you do, you will get the same length. See, 10 divided by 10 into 10 is 10 only. This means for all the intervals whose class size is the same as the minimum class size, the length of the rectangle will remain the same. So, no need to change till 60 to 70 because the class size is 10. Now, the last interval 70 to 100 has class size 30. So perform the same calculation, that is length of the rectangle divided by class size into the minimum class size. In this case, the length of the rectangle is 8 and the class size is 30. So the length of the rectangle will be 8 divided by 30 into 10, which is 2.67. So now the length of the rectangle will be 2.67 and we get the correct histogram. So this is how we draw histograms when we have different class sizes. We convert the histogram according to the minimum class size. I hope there is no confusion regarding this. With this, we have arrived at the end of this video. In the upcoming video, we will learn about one more graphical representation, which is the frequency polygon. And for that, you need a strong grip on histograms. So, practice more and more questions and meet me back in the next video. Now, let's do a quick recap. Histogram, areas of rectangles are proportional to the frequencies. When the class sizes are varying, convert the histogram according to the minimum class size. For that, firstly select a class interval with the minimum class size. Next, modify the length of the rectangle proportionate to the minimum class size. For that, divide the length of the rectangle by class size and multiply it by the minimum class size. For all the intervals whose class size is the same as the minimum class size, the length of the rectangle will remain the same. Thus, the correct histogram is obtained.